Hey folks, if you're just tuning in, I'm doing a very special kind of space radio today. Just taking random questions, keeping it low key. I did a really fun interview a little bit earlier, just because of timing stuff. So if you've got questions, go ahead and fire them away. I'm not doing a full show recording, just going live and keeping it low key today. Meanwhile, while I'm waiting for people, I'm going to start eating cheese because it's my dinner. I can go where I want. Hey, Nancy. Thanks for joining. I'm eating cheese and answering questions. Not doing a countdown. I should have done the countdown anyway. But I didn't want to wait the whole 15 minutes because I have a slightly compressed schedule today. Just did a really, really fun interview with Dr. Emily Holt, an archaeologist. Talked about ancient astronomy, prehistoric astronomy, how we know things, what we don't know. Super, super fun. What kind of cheese? Very good question. I don't know because I'm in a place at Ohio State University called the STEAM Factory, which is like this interdisciplinary co-working space. And there's a little kitchen in here. And I opened up the fridge and look what greeted me. A little cheese platter. There's this kind of cheese. I'm betting this is some sort of Swiss. This is, of course, cheddar. I think this is an Edam. And this is a very lovely, I think this is Boursin. I think this is one of those Boursin cheeses. So this greeted me, and I actually have to go right from this recording right to an event. I'm doing a book event, which means no dinner. So I'm going to eat cheese and you're going to watch it. Oh, wait, I just realized there I didn't angle it well enough. There you go. Now can you see the platter this way? I'll put it back for you. Yeah, so this is the stream where Paul Sutter eats cheese and talks about science. And I'm going to try. Oh, that sounds so good. Some hot pepper infused Monterey. That's really good. Oh, yeah, the Steam Factory takes care of me. They're like, oh, we heard Paul's coming. Let's load up the cheese platter. I'll try not to get crumbs on my microphone, though. That would be in poor taste. Steven, of course I took it broad enough. Look how much I got. There's plenty of cheese for everyone, folks. Astronomy, we're doing a slightly different show today. I did a recording, an interview earlier without the stream with an archaeologist. Wonderful person named Dr. Emily Holt. And I just I couldn't do it at the station today because of various scheduling stuff. But I wanted to jump on and do Q&A. So if you guys have science questions, feel free to ask. I'll answer them while I'm eating cheese. And crackers, of course. So if sometimes my answers start, get a little mouthful, I will be rude. I will be coarse. I don't care. I won't answer your, oh, Jazz, you got my book down in Sydney? Thanks you so much. I really hope you enjoy the book. So I've been mailing out books like crazy. It's been so much fun. It's really cool to mail the books to other countries. And it's really cool that they actually make it because I was a little bit nervous about all that. You're the second person in Australia to get my book that I know of who's told me. I've sent more. Sent one to Matt Woods over in Perth. You know each other? Because there's like 10 people in Australia, right? Mm-hmm. Hold on. That one's good. Pure Ostentation is asking, was there anything on ancient astronomy? And that's exactly what we talked about. We talked about, I mean, you'll hear it on the show Saturday. We talked about prehistoric astronomy and historic astronomy, how we can know if like a monument or a thing actually had astronomical significance. And of course, with prehistoric cultures, you can't know because they didn't like tell us why they did things. And so there's a lot of guesswork involved. There's a lot of challenges involved. Really, really fun field. And then once you switch to historic cultures, people who wrote, they would say like, oh, we did this for this reason. And then, exploring that contrast. It was a really, really fun show. Great interviewee. You'll have to, oh yeah, Jazz, we're on the cruise. I got it. Okay. Oh, we do have a science question because I'd rather just hang out and eat cheese all day. James Mays is asking, burning question: why is it that 80 or 100 kilometers is called the edge of space, when in mind's eye it begins when the density of the atmosphere is the same as space? Well, here's the thing. As you go up, the density of our atmosphere gets lower and lower. The air gets thinner and thinner and thinner. But it's never quite pure vacuum, is it? Like, you can be out at the orbit of Jupiter and there'll be a little oxygen molecule floating around. There'll be a little nitrogen molecule floating around. Are you still in the Earth's atmosphere? That's a little bit hard to tell. And so the 100 miles or the 100 kilometers, the 60 mile, whatever it is, this von Karman line that we call it, it's where the density of the atmosphere drops to such a low level that you can basically call yourself in outer space. It's a totally, totally arbitrary threshold. We could have picked any number. 100 kilometers sounds pretty nice, and it conveniently matches up with some, very low density. You can be at 100 kilometers up, and you will experience atmospheric drag still. The International Space Station does. So it's just totally arbitrary. It's just totally arbitrary because you gotta pick something. I'm drinking water, by the way. Constellation Pegasus, just good old H20. And Joseph Benjamin is asking, why don't we see the light from each star bent around every large object in the sky, hence seeing the same star at different locations? And there's some banging going on. I believe there's some construction, so I gotta shut the door. Hold on, folks. So the reason is, we do see light bent around a lot of things, a lot of around large objects, but it takes a really, really massive thing to bend light in a significant way. Like light coming by our sun gets bent just a tiny, tiny, tiny bit. Like, it's so hard to measure. And you have to wait for just the lucky alignment, right? If you're looking at a distant star, you have to wait for something to pass right in front of it along our line of sight to get that bending. And space is mostly empty. There isn't a lot of stuff. It's going to take a while. There are techniques that we've developed where we just stare at a whole patch of sky for a really long time, like all the stars in a chunk of sky, and just wait for those random interactions. And I know I am waving cheese around in this example. Like, we just wait for and we'll see like a little blink over here, a little blink over there, a little blink over here from the light bending from intervening objects. And this is a way of detecting planets. This is a technique called microlensing. It's a way of detecting planets around other stars, rogue planets. The next mission to launch after James Webb, the W1 mission, will find planets this way, and it'll find like 1 million planets or something. Oh, Stephen is asking, and yes, I am going to talk with my mouth full because I'm hungry. And this is my dinner. So we're chilling. We're having dinner together, folks. This is like a dinner conversation. Jazz, this is like it was on the cruise, wasn't it? I even spit as I talk. So, where is it? Stephen Jordan, if matter travels close to the speed of light near the event horizon when falling in, might it travel faster than the speed when it falls past the event horizon? So, let me... sorry, you are catching the raw stuff here because I got to text someone. Phone's blowing up. So, you are never going to travel faster than the speed of light. But you can view black holes. A totally legitimate way to view black holes is space around it flowing inwards. This is a way you can view gravity. It's totally legit. Like you can imagine here on the Earth, the space around the gravity of the Earth is making the space flow inwards. And that if you want to escape the Earth, you have to fight against that inrushing flow and to get out into orbit. And so around a black hole, you have space flowing inwards. And as it gets closer to the black hole, it flows inwards faster and faster. At the event horizon, space itself is flowing inwards at the speed of light. And then inside the event horizon, space is flowing inwards faster than the speed of light. You being carried along with space, you will never see yourself travel faster than the speed of light, right? Something whizzing by you will never go faster than the speed of light. But you will be carried along so quickly that if you turn around and try to escape, you won't be able to. It's a legitimate way. You can view black holes as like a sinkhole. Mr. E. Dude of the Earth, does the CMB look different from different places in the universe? Pretty much no. I mean, obviously, if you were to jump to... Well, let me backtrack a little bit. This cosmic microwave background is totally uniform to like 1 part in 100,000 or something ridiculous. And it's only when you look at those tiny variations that you start to see bumps and wiggles and variations. And if you go to a different spot in the universe, you will have a slightly different pattern around you. You'll have a slightly different cosmic microwave background. Instead of like a bump over here and a wiggle over here, there might be a bump over here and a wiggle back here. But what stays the same, and this is absolutely key, what stays the same throughout the universe is the statistics of the cosmic microwave background. If you look at, say, the average size of the bumps and wiggles, if you look at, here I go again, if you look at how big they are in the sky, how many big bumps are there, how many little bumps are there, those statistical properties will stay the same throughout the universe, but you might get a slightly different realization of it. You might get slightly different ones. Launchpad astronomy, are we falling into black holes? I certainly hope not. Astro B is very worried. Travel near the speed of light. There's one rival that we might collide with and wreck. Guys, if you're planning on going fast, if you're planning on going close to the speed of light, it is bad news city. You have no idea. You're right. You're absolutely right, Astro B. If you're going really fast, you're going close to the speed of light, and there's like a tiny little dust grain, like a hydrogen atom, just hanging out, it's going to blow a hole in your ship. I mean, come on, people. Just don't try. Just don't do it, all right? Oh, and Isaac Arthur covered it already, so why bother asking me? Any time frame when the black hole photograph will be released. They're a little late. So the Event Horizon Telescope, a network of telescopes around the world, designed to take a picture of the supermassive black hole in the center of the Milky Way. And it is an enormous data analysis challenge. I cannot even describe how difficult. It's one thing to collect the data, which they did, from instruments all around the world. It's a totally different thing to synthesize the data, to combine the data in a coherent way that makes sense. There's tons of niggling little technical issues that will bite you, that if you get it wrong, one little thing wrong, the whole thing falls apart. So I think they originally said, oh, yeah, we'll totally have it in fall 2018. I'm guessing fall 2019, at least, because it's just, and they have to get it right. There's like so much pressure. If they release an image And they start doing some analysis, they have their data, and they screwed up the synthesis of connecting the multiple images from multiple telescopes. They're sunk. They don't get a second chance. They don't get a second chance. They will be pilloried. Is pilloried even a thing anymore? Whatever the academic version of pilloried is, they're going to get it. And Launchpad Astronomy, good job. Yeah, go to Launchpad Astronomy's channel and check out the interview with Jeffrey Bauer. Data analysis nightmare. So I did some of my work. I do some what's called Bayesian analysis, image reconstruction. Whew. It is not for the faint of heart. It is not for the faint of heart. Spotting pure oxygen like spotting glitches is more than that. It's like this instrument collects its data. This instrument collects its data. How do you combine them in a way that makes sense? How do you know that you're combining things in the right way? Because if you combine them in a little bit wrong way, you're just getting your bad image. You have to combine them in just the right way. It's a very, very thorny issue. And I could go into multiple tangents how radio astronomy is not the most statistically rigorous field out there, but there are people trying to make it better, people including me. Chris Scott, what is your opinion with regard to the recent doubt cast on the detection of gravitational waves versus background noise? It was a detection, folks. Come on. We saw gravitational waves. Just we saw gravitational waves. Just give it up. Like, it's important to do those kinds of checks. It's important to do that kind of analysis and make sure, like, are you sure you did it? But we saw gravitational waves. I don't think anyone in the community is worried about that. Like, it's pretty clear. Background noise doesn't look like that. That's the whole key. Background noise doesn't look. Would it be feasible to use an ion engine to make cheese puffs? No. For cheese puffs, you need a lot of air. Like, you need a lot of high velocity air. And ions, are great, but they don't have the mass density that you need. You need a lot of stuff in a low volume. You need a big puff of air. Ion engine just isn't going to make a good cheese puff. Sorry. Question from Jazz. What is the information that escapes a black hole through Hawking radiation? Information, black holes, Hawking radiation, huge thorny mess. I'm going to be the first to tell you. Maybe I won't be the first to tell you. As I eat, by the way, for people just joining, I'm literally sitting here eating cheese and crackers because this is my dinner, because I have to go right from this to an event. And it's a speaking event, so I need my energy. I need to carb load so I can run that marathon of doing a big public event. And I swear, like, information, once you start wading into the waters of information, black holes, and radiation, you're just asking for trouble. Just big trouble. Because we don't know a lot about black holes. We don't know a lot about quantum mechanics at black holes. We don't know a lot about information. We don't really have a rigorous definition of information in a quantum mechanical sense. What we have are some hints and clues and like vague pictures of there's something related between black holes, ideas regarding information, and ideas regarding, of all things, thermodynamics, like entropy and temperature. There's these like weird thin strands that seem to connect these concepts. What we're trying to do now is make those strands thicker, make them into ropes. We're trying to push. We're trying to understand. What is it? What does information mean on a quantum mechanical level? We don't know. What does entropy mean when it comes to a black hole? Well, that's a little bit hard to define, isn't it? Is this all a coincidence? Does it lead to something more important? It is just so hard to tell. And I swear, if you're not careful, and I know there's tons of videos out there about, and I've done podcasts and episodes about black holes and information theory and Hawking radiation and all that. I'm asking you to just tread carefully because, like I said, it can just get you into trouble. And we don't want any trouble, do we? We don't want any trouble, do we? Corey, good to see you. Thank you so much for contributing to Patreon. That really means a lot. That really means a lot. Corey Duvall, latest Patreon contributor, everyone. But give him a big, big round of applause. Also, Corey, I hope you don't mind me saying this. Corey is a fantastic ballroom dancer. I know that for a fact. And I know that, one, because I've seen him dance. And two, which do you think is worse, being drawn into a black hole or having to do a Viennese waltz to waltz timing? Guys, I cannot tell you. The Viennese waltz is meant to be fast. It's one of these dances that relies on rhythmic momentum where you build tension and release tension. You build tension and release tension. And you need that constant movement, that 1, 2, 3, 1, 2, 3, 1, 2. You need that momentum to carry you on the floor. If you try to do the Viennese waltz to a slow timing, the momentum falls apart. You can't build and release the tension in the right cadence. Instead, you spend so long, you end up getting locked, and then you have to force your legs to move in the right patterns, and you don't get that magical Viennese waltz quality where you look like you're just floating along the floor. So I'm gonna have to say, Corey, that falling into a black hole was worse than trying to dance a Viennese waltz to waltz timing. I sound like I know human dancing. I'm an amateur. I ballroom dance, folks. I ballroom dance, I'll admit it. So you're getting the real stuff here. We only have a few minutes left before I gotta get going. Where I gotta get across town for the event. And I just realized, look what I've done. Look what you make me do, people. I had half a cheese ready to go. I ignored it, and I started loading up another cracker. This is me. And I realized this was a public plate of cheese. I've totally owned it. It has my saliva on it now. I've basically licked this entire plate of cheese, which means I guess I get to finish it. Nancy Graziano, which is more difficult, modern dance like a siren modern dance or the Viennese waltz? Look, I'm personally of the view. I have two answers here for you, Nancy. Different kinds of dance are equally difficult. I don't think at a professional level, at a competitive level, at a high level, a Viennese waltz is incredibly complicated. It may look simple because it's very simple patterns, especially with the leg work, but that's tough. It's very, very tough. And you can go into enormous detail, ridiculous detail about foot placement and weight and distribution. That said, so on one hand, I want to say no, the Viennese waltz is as difficult as modern dance, but modern dance is a category of movement. It's not a specific dance with certain rules associated. There are rules associated with modern dance. I'm not the person to tell you the rules. Kate St. Amand from Siren would be the one to tell you here's what a modern dance looks like. The modern dance that we used in TikTok, or the modern dance that the dancers and choreographers used in TikTok. These are dancers that have been doing it their entire lives. These are, choreographers that live and breathe this stuff every single day. This is not a hobby for them. this is not like a lifestyle. Like this is their life. Like this is their thing. They've been doing this for so long that they are so, when you see a high level dancer, it's something else to watch. It is like they're so in tune with their body, and they know, like, there's like muscles that probably don't even have names that they know how to activate in just the right way to give just the right nuance, to connect to the music in a certain way, to express a certain emotion or story. It is just something else to watch. I'm always blown away by dance. And folks, I know we're getting like way off on a tangent. If you get a chance to see live dance, and you get to see a chance to see live dance up close, not on a TV screen, not from the nosebleeds, but up close, it is another experience. Oh, thank you, Siren Modern Dance. Apparently, modern dance has no rules. There's only one rule in modern dance, and that is that there are no rules. So there you go. I was wrong. Viennese waltz, a lot of rules. A lot of rules. Thank you, Constellation. Thank you. I'm getting a little parched. I gotta slow down on this cheese. But it's so good. So thank you, Steam Factory. Unfortunately, I do have to go here. Do I have an opinion on nuclear power? Nuclear power exists. Unfortunately, I would love to keep chatting, folks. Actually, in the future, I have plans to do more informal live streams like this. I haven't set a schedule or anything. Just keep your eyes peeled. I'm going to be doing more informal live stream Q&As so we can chat, so we can hang out, so we can be best friends. Because I don't have any real friends. You're the closest thing I have. But I will chat with you next week. I hope everyone if you celebrate Christmas, have a good Christmas. If you don't celebrate Christmas, just have a time. Just celebrate life, okay, for me. And I will enjoy the cheese. Thank you very much. I'm zipping up a cracker bag, so I stop. I might take that in my car with me to the next event. But I will see everyone next week. Thank you so much.